Morning, guys. It's Mrs. Dugan. You should have a couple things ready while you're watching this video. First, you should have your GUS. You should have completed your Do Now, and you should have this note sheet that you can see on my screen, Law of Conservation of Energy. I'm going to go through a couple notes for today. This shouldn't take very long, but you do have 3 tasks to complete today. You have your Law of Conservation of Energy notes. You then need to use the simulation, your notes from the simulation, and the notes that we have taken to answer the 10 questions on the PhET simulation questions puzzle piece on Schoology. And finally, you'll have an exit ticket that needs to be taken at the last 5 minutes of class. It's just 4 questions. There's no grade attached to that one. That one's just for me to see what we need to go over when I come back. Okay, so let's go ahead and get started. Okay, make sure you have this Law of Conservation of Energy note sheet in front of you. We're going to go through a PowerPoint. Again, this shouldn't take too long. All right, so we're going to talk about the Law of Conservation of Energy. Now, if you have heard anything, been listening closely, I've said energy cannot be created or destroyed. It's very similar to matter, okay? We've talked about mechanical energy and how it stays the same, and the Law of Conservation of Energy shows us that energy cannot be destroyed, but it can transfer from one thing to another. All right, so the bolded the red words are the ones that you need to write down in the blanks. Okay, mechanical energy. Mechanical energy is the sum of all forms of energy in a system. Okay, so when we looked at our PhET simulation, we saw that there was another type of energy that was included in our mechanical energy when we added friction, and that was thermal energy. So those are all different types of energy, but we still add them up and they still equal the same as mechanical energy. It's not just the sum of kinetic and potential, but it is the sum of potential, kinetic, thermal, electric, potential, all of the things that we're seeing, those all equal mechanical energy. Now, mechanical energy, this includes kinetic, potential, thermal. All of them are measured in a unit called joules. Okay, and we always say just put J next to our energy form. Okay, again, this is joules. So as we saw in the skate park, mechanical energy always stays the same, but kinetic and potential are going to change based on their position. Remember with the skate park, as the skater went up the ramp, the kinetic energy increased, but our potential energy increased, but the kinetic energy decreased. As the skater went down the ramp and it picked up speed, then kinetic energy increased and potential energy decreased. So again, just like what I just talked about, mechanical energy, when we talk about kinetic energy and potential energy, we have a proportional relationship with speed. We've talked about this before. It's in your notes. As you increase speed, kinetic energy also increases, okay? Proportional. As one goes up, the other goes up. However, we are going to see the inverse happen in potential energy. As speed increases, potential energy decreases. So the reason why kinetic energy is so high at the bottom of the ramp is because it's increasing speed. All right. The reason why kinetic energy is so low at the top of the ramp is because the speed is at its lowest. All right. Just as we know, mechanical energy stays the same throughout all points. All right. You don't change mechanical energy because it's just the sum of the numbers. So if you think all the way back to when we first started talking about energy, I had you say, okay, find as many sums, so add as many numbers as you can to make 4. And we had 1 plus 1 plus 1 plus 1, 2 plus 2, 3 plus 1. Okay, it's the same thing. Mechanical energy. If we have 3 joules of kinetic energy and 1 joule of potential, it's going to equal 4. If we have 4 joules of potential energy and kinetic energy 0, it's still going to equal 4. All right, mechanical energy stays the same at every single point. Again, I said it earlier. This week, I could get that tattooed on my forehead, and I'm pretty sure most of you would still miss it on the quiz. So remember, mechanical energy always stays the same. It does not change. It does not increase. It does not decrease. Mechanical energy always stays the same. All right, so this is a photo of the relationship between kinetic and potential. We're going to talk about the law of conservation of energy, but I'm going to hit on it really quickly. The law of conservation of energy says that energy cannot be created or destroyed. It's just going to be transferred from one type to another. And we can see this in this picture. So let's just call her Sarah. As Sarah throws the ball up into an arc so that Josh can get it, we're going to notice that when she initiates the throw, okay, she's released the ball, it's been thrown into the air. Green is kinetic energy. Our kinetic energy is very high. We have some potential energy, but even after she's thrown it, it's slowing down, okay? The potential energy is increasing as it makes its way up the arc. Okay, and that's because the speed of the ball is slowing down. Kinetic energy is transferring into potential energy because our speed is decreasing. Now, remember, at the top of our arc, we're always going to have a nanosecond of pause. All right, and that means that at that peak, the potential energy is going to be the absolute highest. And if it's the absolute highest, that means that there's no speed. It's completely still. So you have fully potential energy. Then as it starts to come back down to Josh, we see that the kinetic energy starts to increase and our potential energy starts to decrease. Why does that happen? Talk to your neighbor. Why does that happen? Why does it happen that our potential energy decreases and our kinetic energy increases? Okay, come back. 3, 2, 1. All right, what happens? Why is it that potential energy is decreasing at this point and kinetic energy is increasing? Well, the reason for that is because kinetic energy increases when speed increases. So, as it's coming down the other side of the arc, our speed increases and potential energy decreases. There's another thing that you could have said. You could have said, well, Mrs. Dugan, the height, the amount of space, the distance between the floor or earth's surface and the ball is decreasing. We know that with potential energy, it depends on height. So height, if you, the smaller distance between the ball and the ground, the less potential energy. Okay, so you could tell me that speed has an impact on this and the height has an impact on this. All right, getting into the law of conservation of energy. The law of conservation of energy states energy cannot be created or destroyed. It can simply change from one form to another. So we just saw that again. I'm going to go back to this one. It's not that energy is being magically, I don't know, poofed away. Okay, it's just changing. All right, think of butterfly. A caterpillar and a butterfly are still the same organism. There's just a change. Okay, so the same thing happens with our energy. Kinetic energy transfers into potential energy. It transfers into thermal energy. It transfers into these different forms of energy so that we keep the same mechanical energy. All right. If you think back to the skate park, when we added friction, our kinetic energy and our potential energy did go lower. However, thermal energy was introduced. The energy did not get destroyed, it just turned into heat and was released from the system. Mechanical energy stayed the same. I'll show you a version of that in another video so that you can see what I'm talking about. All right, so again, here is Martha, and she's playing golf. And this is a great illustration of how mechanical energy stays the same even when we have a transfer of kinetic and potential. So Martha hits the golf ball. It is at its peak kinetic energy, okay, peak movement. And as it's making the arc, we're going to see that kinetic energy is transferred into potential energy. At the top of the arc, we have a full potential energy, and as it makes its way back down to the green, we have our full kinetic energy. Now, if we look right here, we're going to notice that these are equal. There is a point at on the arc where it's going to have an equal kinetic and equal potential. All right, that's the sweet spot. So where that's going to happen is going to be around in the middle of the arc. So if we covered this up and we cut it in half, the middle of the arc or the middle of the hill or anything is going to be where kinetic energy and potential energy are completely equal. Okay? Now, if energy cannot be destroyed, then it's transferred from one form to another. All right, I've said that a couple times now. You cannot destroy energy, it doesn't happen. All right, it is just transformed. Kinetic and potential energy are transformed into thermal energy as friction is introduced to the system. The kinetic energy is transformed into potential energy in a system. Okay, so all of that happens because the law of conservation is true because we can measure these energy forms and we can see how much energy is really there. Not in seventh grade though, when you get to college probably or higher. All right, so if you throw a ball into the air, kinetic energy changes into potential energy as it reaches the top. We know that the opposite happens on the way down. Potential energy is changed to kinetic energy on its way down because we are increasing our speed. All right, we're going to talk quickly about work. This isn't a big topic in seventh grade, but you still need to know. So if you think back to the first day we talked about energy, I had a do now that said, what is energy? Many of you said, well, it's a food source. It helps us do things. You're right. Energy is the ability to do work. And work is the transfer of energy to an object by a force acting on it. All right, so I've got this Dr. Pepper because it's my favorite soda. Hint, hint. Okay. Right now, it is sitting in my hand. Okay. Sitting in my hand. It has a lot of potential energy. However, if I take it and I move it up, then I am exerting a force. Now, as it's moving up, I am doing work on the object. All right. I am moving, acting as a force, pulling it up and doing work. It's just transferring energy because if it just did this and there wasn't a force acting on it, it would stay like this. However, if I take my hand and I transfer the energy from potential to kinetic, then I am doing work on it. Okay. So work is the transfer of energy to an object. Going back to this, you saw this with your slingshot too. One of the questions was, where does the energy go when you released the rubber band? Well, the rubber band transferred its energy into kinetic energy into the object so that the marble could actually get slung all the way to, some of you had like 98 centimeters. Okay. So we did work on the marble because we transferred energy by using a force so that it could move. Now, you can increase the amount of energy in a system. And the way that you do that is by having a force acting on it. Okay, think about how many of you have ever pushed like a weight sled. All right, the weight sled has If you don't know what I'm talking about, I'll put a picture up there. I'll talk about it tomorrow. But it is this contraption that you just put plates of weights on, or look it up. You'll have the internet. Okay. You put plates, these big plates, and you can stack up as much weight as you want. All right. That in itself is a system. Now, say you put 200 pounds of weight on this weight sled. There's a lot of potential energy there. All right. Now I can increase the amount of energy. I can transfer more energy to the system by trying to push that sled down the field. All right. I'm increasing the amount of energy because I am pushing on this this sled with a certain force, and I'm adding energy to the whole system. Remember, the system is going to be something that that's kind of enclosed. Our system with the weight is the sled and the person pushing it. So I'm increasing my energy to, I'm increasing the energy by pushing and putting a force on this weight. And those are our notes for today. Okay, I am going to have another video where I talk about the different portions of mechanical energy and thermal energy. So make sure you watch that one individually. That way you get a little bit better of an idea of what I'm talking about with law of conservation of energy. Okay, make sure that you are on your best behavior, and I will see you tomorrow. We are in the library tomorrow. Thanks, guys.